Welcome back to another lecture. I'm going to continue talking about resonance structures. So last time we covered a good number of examples, and also in this lecture, and I will keep doing the same thing. Okay, so when it comes to resonance structures, we said we do not break like technically is like a sigma bonds, stay as it is. But if you have a positive or negative charge, you can share it with neighbor through and like using a lone pair or like a pi bond. So you will get resonance structure if the neighbor atom has a lone pair or involved in a double or triple bonds. Okay, so for example, in this cases, as you see, any atom that you pick is an octet, and like it's not going to be a good idea to make a double bond between, for example, carbon and oxygen, because in that case, carbon will have more than 4 electrons, for more than 8 electrons, and that's not going to be correct. And again, nitrogen is already octet, so it's not going to be looking for another electron. How about this oxygen? Oxygen is octet, so there's no point to make another lone pair double bond here, because if we do it, then we will have 10 electrons there. How about this carbon? This carbon is already has 2 hydrogens and a +1 methyl group. So if I draw a circle on this carbon, that carbon is already 4 plus 4. Sigma bond is 8, and no point actually to make a double bond between carbon and oxygen. So none of them is going to be a good move. Okay. Again, we're talking about localized versus delocalized, and whenever we say localized means it's fixed, it's not moving, but delocalized, the charge, it can move, either positive or negative. So in this case, the positive charge was, the positive charge was shared with this technically carbon, and the way we did it, we moved, and you can say we moved the double bond here. Now we put the double bond here. When we put double bond there, we will have a positive charge there. Okay. And as you see, we are going to get a mixture of both resonance structures, and 50% of the time, this carbon, it has a positive charge, and 50% of the time, the one on the left is going to have a positive charge. So you can say the positive charge is distributed over 3 carbons atom, 1, 2, 3 atoms, and we show it by dot lines, and that means the double bond, it can be anywhere, or the positive charge is going to be between them. Mixture of them it will be the correct representation of Lewis structure of Lewis structures that you see in front of you. Okay. Next. In all, like in organic chemistry, most of the cases you will be dealing with carbon, nitrogen, oxygen, or fluorine atoms. We can have, of course, chlorine, others. But whatever you do, you have to keep carbon, nitrogen, oxygen, and fluorine octet. Whatever you do, okay? Always keep it octet. The best Lewis structure is a Lewis structure that has all the atoms are octet, and also formal charges are equal to 0. In this case, for example, and carbon is octet, formal charge as well is 0. How about oxygen? Also is octet, and the formal charge is 0. So that's perfect. Okay, that's perfect. What can I do with this one? I can actually I can draw a resonance structure for it, and the resonance structure, it will be something like this. So okay, forgive me. Okay, the resonance structure, okay, it will be this. It will be, we're going to have a carbon, okay, attached to, okay, oxygen, and we moved the lone, we moved those 2 electrons to oxygen. Oxygen already has 2 lone pairs, and you give it 1, so now it has -1 charge, while oxygen carbon, it will have a positive charge. Which one is more stable? Of course, this, because it has 0 and 0 as formal charges. How about the second one? The second one, oxygen is already octet, and it has a 0 formal charge. Okay, but you can share the lone pair from oxygen with this bond, with this carbon, and if you did, then the 2 electrons will move to next carbon, this carbon, and it's going to have a negative charge. Okay, so let's draw it. We have oxygen. It has 2 lone pair. We're going to use one of the lone pair to make a double bond, and if that one happened, now this carbon, okay, this carbon, okay, it will turn octet. So no need to have a double bond with another carbon. And that means the 2 electrons will move there. And now you will have a lone pair on that carbon. And this carbon is going to have, okay, is going to have -1 charge. Okay, now if you look to previous carbon, this carbon is 0. It has 0 formal charge. And how about this carbon? Also 0 formal charge. So if all of them are 0, how come on the right side we have a negative charge on carbon? There must be somewhere that like turn to a positive, to an element with positive charge. Let's check oxygen. So oxygen, I'm going to draw a circle around it. Oxygen is a group 6, but I see only 5 electrons around it. So now oxygen turned to +1. Okay, now on the left side, I have all atoms are octet and the formal charge is equal to 0. That's perfect. Right side, I got 2 charges. Okay, we said the best Lewis structure, the one that has all the formal charges equal to 0. So in this case, this is going to be the best Lewis structure. Another example. Okay. This is going to be, is the same as the top one. Is a copy paste actually of the top one, and I already wrote the answer for it. But we have a couple of examples here, and we have 5 of them, and I'm going to show you what's going to be the correct answer for each one. Okay. Now, listen carefully here. I'm going to design some questions. And sometime while I'm lecturing, I'm going to say, this is a question 1. I will draw the Lewis structure for it, and I'm going to ask you, which one is the best Lewis structure? So whenever you see that question, pause the video, choose the correct one, and then whenever you see the question is popping up, then answer it, and after that one, continue the video. Okay, so in this case, what do we have? We have a carbon, okay, carbon. So this is going to be carbon that is attached to 2 hydrogens and is involved in a double bond. And of course, this carbon is going to have 1 hydrogen attached to it. Okay, what else? We have a carbon here, and that it has negative charge. Okay, so that means it has a lone pair. In order to be octet, we need to have 2 more hydrogens. Okay. Now, what I'm going to do, I'm going to take this lone pair, and I will share the lone pair, okay, with this carbon, and I will make double bond there. And what's going to happen with this, double bond? The double bond, it will move to this carbon, and that's going to give me this structure. So I get carbon with 2 lone pairs. With 1 lone pair, 2 hydrogen atoms. Okay, maybe I should draw it this way. We have lone pair, and now we have a carbon here. This carbon is involved in double bond. I think I need more space, so okay. Let me move everything to the left side and shrink size as well. Sorry. Okay, so we're going to get this. We're going to get carbon that has 2 hydrogen atoms. Will form a double bond. Okay, and then this carbon is attached to another carbon and an hydrogen atom. Okay, and the highlighted carbon now will have lone pair and 2 hydrogen atoms as well. So here you go, 2 hydrogen atoms and a lone pair. Okay, negative charge from the left side, from right side, move to the right side. Okay, so this is going to be structure number 1, and that one structure number 2. Structure number 2 is exactly equal to this. Okay. Forgive me. It's going to be equal to this. Okay, which is equal to. Okay, this one, it will be a resonance structure of this one. Okay, so if I want to draw hybrid of them or mixture of them, this is going to be the answer for it. So you draw 3 carbons because totally you have 3 carbons, and then you will draw dots there, and you say minus. What does it mean? It means in one of this carbon, I'm going to have a negative charge, and negative charge is going to be either here or there. Okay. Next structure. Okay, so let's take this molecule. Okay. Next structure. Okay. We have oxygen. Okay, that's its neighbor to a double bond. Okay, oxygen is not active. So what do I need to do with it? I'm going to give oxygen 2 lone pairs. Okay, is it possible to share one of these lone pair with that carbon and then move this one there? Yes, it's possible. Then what will happen if we do it? We're going to get this structure. We're going to get double bond, and then we have a carbon, and this carbon is going to have a negative charge. Okay, and of course, you have carbon there. This is equal to oxygen and with negative charge or lone pair there. And of course, there is a double bond here. Let me draw it with another, okay, another color. Okay, so oxygen, in order to be active, needs one more lone pair. So here you go, one more lone pair. And oxygen is going to have +1 charge, and this carbon -1. Okay, question. Okay, so listen carefully. Okay, this is going to be a question 1. Question 1. So question is going to be this: between A and B. Okay, A and B, which one is more stable? Okay, so which one is more stable? A or B? That's the first question that you will see. Okay, so I already showed you the structure for it. Technically the Lewis structure for it. Okay, another example. Okay, now any oxygen that you see must be active. So okay, the top one is involved with double bond, so we need to give it only 4 electrons, but the bottom one, okay, both of them, my bad, both of them, we need to give them 4 electrons to make them active. Okay, now, is it possible to move this, for example, one of the lone pair here, and then say make a double bond here? No, that's not going to be correct. Why? Because this oxygen is already active. No need. Okay, no need to accept another electron. But how about this? Can we move this lone pair there and move the pi bond there? Okay, yes, it's possible. So that's going to give me this structure. I get double bond here, and I will leave oxygen with 1 lone pair, and this oxygen is going to have 3 lone pairs. Okay, next formal chart for this oxygen, it will be +1. That one is -1. Okay, well, this one is 0, and that one is also 0. Okay. Okay. Now another question. Okay, call this one A, B, and this one it will be, forgive me. Okay, let me cut this one. That's your second question. Okay, second question. Again, which one is more stable, A or B? Okay, which one is more stable, A or B? So pause the question. Pause the video, answer the question, and then move on. Okay. Okay. Next, we have nitrogen. Okay, nitrogen is not active. So what do I need to do? I'm going to give it a lone pair. Carbon, it has a lone pair. Okay, remember, carbon is going to have 1 hydrogen more to be active. Okay, so is it possible to move this lone pair and put it here and then move that one there? Okay, let's see what will happen if we do it. And that's going to give us nitrogen. Okay, nitrogen 2 will get 2 lone pairs, and then it will have a single bond with carbon. Okay, double bond here with this carbon, and then okay, you have that one. Okay, so as you see, double bond used to be there, and now double bond moved here. Okay, so how about the formal charge? Okay, calculate the formal charge for this nitrogen. Okay, but for now, I can tell you that this carbon is 0. Okay, what's the formal charge for that nitrogen? Okay, and now the formal charge for carbon here is -1. Okay, while that oxygen, that nitrogen is 0. Okay, so A, B. Okay, third question. Okay, third question. This is question 3. Okay, again, which one is more stable? Okay, I'm gonna pause here, and I will see you soon. Thank you very much.